Morning all of you. I am P. Gomati, Assistant Professor, Department of Mathematics. So in this video lecture we are going to see about normal subgroup. So I have already defined you what is a group and what is a semigroup and what is a monoid, and we have seen some examples in that. So today we are going to see about normal subgroup. So what is a normal subgroup? Suppose if you have H to be a subgroup of G under star, then H is said to be a normal subgroup of G. For example, X belongs to G and for H belongs to H, X star, H star, X inverse belongs to H. That is, it is contained in H, then we call it as a normal subgroup. So alternatively, we can call this as a subgroup H of G is called a normal subgroup if H star X is equal to X star H for all X belongs to G. So let us see some basic theorems. So theorem number 1, the intersection of any two normal subgroups is a normal subgroup. Let us take two subgroups, that is H and K, to be a two normal subgroups, which will give H and K are subgroups of G, because if it is a normal subgroup then it should be a subgroup of G. Then H intersection K is a subgroup of G. That is, already we have proved this in a theorem. If H and K are subgroups of G, then H intersection K is a subgroup of G. Now we have to prove that this H intersection K is normal. That is, let us take some other element from G, that is X belongs to G and H belongs to H intersection K. Then X belongs to G and H belongs to H and H belongs to K. So this will give X belongs to G and H belongs to H and X belongs to G. By the definition of normal subgroup, this can be written as X star H star X inverse belongs to H, and similarly X star H star X inverse belongs to K. So from this we can easily say that H and K are normal subgroups. So from equation 1 and 2, X star H star X inverse belongs to H intersection K, that is H intersection K is a normal subgroup of G. Next, let us move on to the theorem 2. So the statement is, let G and G dash be any two groups with identity element E and E dash respectively. If F from G to G dash be a homomorphism, then kernel of F is a normal subgroup. So let us prove this. So we already know K is nothing but the kernel of F is given by X belongs to G such that F of X equal to E dash. That is what you have to collect all the identity elements and put together in a group, that is called as the kernel of F. So we know that kernel of F is a subgroup of G. So you have to prove that kernel of F is normal. So how to prove this normal subgroup? So X star H star X inverse belongs to K. That is, take an element X belongs to G and H belongs to K. So consider the mapping F of X star H star X inverse, which is equal to F of X star F of H star F of X inverse. Because F is a homomorphism, we can write F of A star B equal to F of A star F of B. So from this F of X star, F of H is nothing but our E dash star F of X inverse. So using the property identity, so F of X star E dash is nothing but F of X, so star F of X inverse. So you combine these two, so F of X star X inverse, that is X star X inverse is E, so F of E, that is nothing but E dash. So from this F of X star H star X inverse is equal to E dash. From this we can derive X star H star X inverse belongs to H, that is K equal to kernel of F is a normal subgroup of G. So next, the most important theorem, fundamental theorem of homomorphism. So the definition is, every homomorphic image of a group G is isomorphic to some other quotient group of G. So this can also be taken as, let F from G to G dash be a onto homomorphism from the group G by K, which is isomorphic to G dash. So to prove a group from F from G to G dash is an homomorphism, it is enough to prove that this group is well defined one to one on two, and the group is homomorphism also. Let us take an element K, which is a kernel, and clearly we have already proved K is a normal subgroup of G. So we can easily prove G by K is isomorphic to G dash. To prove phi is well defined, that is, we are defining the function phi and you have to prove the function is well defined. So for this you have to consider the function K star A is equal to K star B, which implies A star B inverse belongs to K by the definition of normal subgroup, and this implies F of A star B inverse is equal to E dash. So from the definition of homomorphism, this can be written as f of a star f of b inverse equal to e dash and f of a star f of b equal to e dash. So from this f of a equal to e dash or f of a equal to f of b. So what is our f of a? That is nothing but phi of k star a, and f of b is phi of k star b. So from by taking k star a equal to k star b, we have derived phi of k star a equal to phi of k star b. So from this we can easily say phi is well defined. Next, let us prove phi is 1 to 1. This is the reverse process of whatever we have done in the previous step. That is, you have to consider phi of k star a equal to phi of k star b, and you have to prove k star a equal to k star b. So let us take this phi of k star a equal to phi of k star b. That is nothing but f of a equal to f of b. So post multiply by f of b inverse. So f of a star f of b inverse equal to f of b star f of b inverse. So combine the elements together. So f of a star b inverse equal to f of b star b inverse. So b star b inverse is nothing but e. So f of e. So f of e is nothing but e dash. So from this we can easily say k star a equal to k star b, or phi is 1 to 1. And the next one you have to prove phi is onto. So onto is nothing but, since the given function f is onto, we can easily say that phi is onto. And the last one, to prove phi is a homomorphism, you have to prove phi of k star a star k star b is equal to phi of k star a star phi of k star b. So consider the left hand side. So that can be written as phi of k star a star b, which is equal to f of a star b. And by the definition of homomorphism, this can be written as f of a star f of b. And f of a is nothing but phi of k star a star f of b is nothing but phi of k star b. So phi is a homomorphism. So since f phi is onto 1, onto, and well defined and homomorphism, we can easily say that this group G by K is isomorphic to G dash. So we have derived the fundamental theorem of homomorphism. Thank you.